Hey young men, Mr. M here. Alright, so today we're gonna start looking at the vocabulary or terminology for potential energy and kinetic energy. So let's get started. Our first word here is energy. Energy is the ability of a system or something to do work. Energy is required for changes to happen within a system. We're going to look at some things that have energy. So by looking at this chart this list that we have here, different things that have energy are a book on a desk, your body, a machine, a computer, a flashlight even when it's off, and a stretched rubber band. These are just a few things that have energy. We're going to start looking at when an energy has potential and kinetic energy. Now, one very important thing to remember, so you need to write this down in the blank space provided there in your square, is right here what I'm circling. Something known as conservation of energy. Conservation of energy says that energy is never created nor destroyed. So that's what we're going to be looking at today. How energy just changes from one form to another. Alright, if you're not done writing that down, go ahead and pause it and then replay the video or continue playing the video. Let's look at the next word. Potential energy. Potential energy is energy that is stored in a system or object. Now, when an object has potential energy, it has the ability to do something. Whether it's the ability to move, a person's ability to stand up. Point is, potential energy gives you the ability to do something, to do work. So some things that are very important, and you need to write this down, exactly what I'm circling here, is that potential energy increases, meaning it goes up, with height, or when the object is compressed, which means squeezed, or when the object is stretched out, such as a rubber band. So again, if you're not done writing this down, go ahead and pause the video and then continue playing it. Let's move on to the next word. Actually, these are examples of potential energy. I forgot about these. Alright, so let's look at this very first example right here. When you have a ball at the top of a hill, it has potential energy but no kinetic energy. So it has the ability to start moving or rolling down the hill, as you can see here in the picture. Let's look at this next one right here. The higher the ball, the greater the potential energy. So here we have a wrecking ball, and just as we've talked about with height, more height, we get more potential energy. So if this ball right here ended up swinging to a height right here in this spot, then it would have the most potential energy there. So the higher it goes, the more potential energy it has. Let's look at the example here of the boy with a bow and arrow. It says the more the bow is pulled back, the greater the potential energy. So this boy is stretching the bow backwards. So the more he stretches it, the more potential energy the bow has to be able to move later on. Let's look here at this rubber band. Same thing, when you stretch a rubber band, you have potential energy. So the more you stretch it, the more potential energy it has. So chances are that it'll go farther when you actually let it go because it has more potential energy. Let's look at this last picture here of this boy with a slingshot. Same concept here. The more this boy pulls the slingshot back, the more potential energy it has. Therefore, when he releases it, whatever object is there will go farther and faster. Now we're gonna answer one question on the next slide about potential energy. Here we have 4 different springs. These springs are being stretched, but they're not all stretched the same amount of distance. Some are stretched more than others. So here's my first question for you. Which spring would have the greatest potential energy? Alright, so go ahead and pause the video here, try to see if you can answer it, and then continue playing the video so I can give you the answer. Alright, so hopefully by now you have an answer to this question. Which spring has the greatest potential energy? Alright, so we have to remember, the higher an object goes, the more it's compressed, which means squeezed, or the more it's stretched, the more potential energy it has. So what we're pretty much asking here is which spring is stretched the most? And the answer would be spring 4. Right here, it is stretched out the most, so it has the greatest amount of potential energy. Let's look at this one. Which object has the least potential energy? So now we're looking at the opposite of the most. So go ahead and pause the video, get an answer, and then continue playing the video so I can give you the answer. Alright, so by this point you should have determined which spring has the least or the smallest amount of potential energy. So if spring 4 had the most because it is stretched out the most, then the opposite would be the one that is stretched out the least. So the object that has the least potential energy is spring number 2 because it is stretched out the least. Alright, let's move on to the next vocabulary word. Kinetic energy. Kinetic energy is the energy of motion. That is very, very important. Now please make sure you write down this that I'm circling right here. Kinetic energy is at its greatest point at its lowest. So just the way potential was the greatest at the highest point, kinetic energy is the opposite. It has the most kinetic energy at its lowest point. So let's look at some examples next on the next slide. Alright, so right here at the top, we have the same example that we saw before, but now we have some more information here. We saw that the most potential energy was at the very, very top of the hill, and we said that it had the potential to roll down the hill. So as it rolls down the hill, it is gaining kinetic energy. So at its lowest point, which is right here, the ball has 100% kinetic energy, the most that it can have. Let's now take a look right here at this bow and arrow. We also saw an example of a bow earlier and said that the more you stretched it, the more potential energy it had. Well, when the bow is released, it starts to move, meaning it has motion, and therefore the object now has kinetic energy. It is transferring to that. Let's now look at this example here of a boy pushing a ball down a hill. Once again, at the very top of the hill, the ball has the most potential energy it can have. It has the potential to roll down the hill. Once the boy pushes the ball down the hill, it is now moving, or it has motion. Now that it has motion, it has kinetic energy. Let's look at this last example here of a roller coaster. At this point right up here, it has the most potential. Once it starts to move down the hill, it is now in motion and now has kinetic energy, or it's starting to change into kinetic energy. Let's look at the next slide. We have a girl here playing on a swing set. So we want to figure out here where it is that we have potential energy and where we have a lot of kinetic energy. So let's try to remember. Where was it that we said an object has its most potential energy? At its highest or lowest? Very good. An object has the most potential energy at its highest point. So up here, the swing would have 100% potential energy. So where is it that the swing would have the most kinetic energy? Great job. Down here, the swing has 100% kinetic energy because it's at its lowest point. So now let's answer two questions here. Question 1, at which point, A or B, does the swing have the most kinetic energy? So if we labeled our swing already, we should be able to answer this very quickly. Which one has the most kinetic energy? Great job. At point B, right here. Let's look at the next question. At which point, A or B, does the swing have maximum or the most potential energy? So once again, since we labeled it, this should be very, very easy to answer. Where does it have the most potential energy? Great job. It has the most potential energy at point A, which is right up there at its highest point. So between A and B, right here, it's starting to change. Okay, the energy changes from potential to kinetic energy. So remember on the first slide how we talked about energy never being destroyed, nor it's created? That's because it's just changing from one form to another. Let's take a look at our next slide.